All right, welcome to the 1-7 video. Here we're going to solve radical equations. All right, the first step whenever it comes to solving radical equations is to isolate the radical. And as you recall, the radical is that heartbeat symbol, right? So whenever you see that, you want to get that by itself, right? Isolate. I'm going to isolate myself. You're by yourself. There's nothing else going on with it. The second thing we're going to do is we're going to square both sides. Square both sides. And then the last thing we're going to do is we're going to solve any remaining equation. All right. So sometimes we don't have to isolate the radical. Right? Sometimes it's already isolated for us. So my first example, if we take a look here, the square root of x equals 7, right? So if we take a look at this guy, the radical, right, the square root of x, there's nothing being multiplied in front, right? There's no number here, and there's no numbers after it, right? So all I need to do is go to the second step, which is square both sides. So I'm going to square this side and square that side. Right, because the index is a 2, I raise it to the power of 2. Right, so this is squaring both sides. When I square this side, I end up with an x. When I square the right side, 7 squared, 7 times 7 is 49. Not 7 plus 7, not 7 times 2. Right, 7 raised to the second power is 7 times 7. And then we're done. Right, x is all by itself, and we have nothing else to worry about. Right, so sometimes we don't have to isolate the radical. Sometimes there's no remaining equation. All right, let's take a look at another example where there is an equation afterwards, right? So here, let's take a look. V minus 4, the whole thing equals 3. All right, so there's no multiplier in front. There's nothing being added or subtracted to the radical, so it's by itself. It is isolated. All right, so I don't have to worry about step 1. I'll go to step 2. I'm going to square both sides. So I put the whole thing in parentheses, raise it to the power of 2. This whole thing in parentheses, raise it to the power of 2. Now this gets rid of the radical, and I'm left with v minus 4. Now, 3 to the power of 2 is 9. Now, I've squared both sides. Now, I have to solve the remaining equation. I need to get v by itself. So my next step, add 4. And 9, 10, 11, 12, 13.
Mr. Richardson, if you're available, could you dial 7114? Mr. Richardson, if you're available, could you dial 7114?
All right, let's take a look at the next example here. What happens if I have something like negative 8 plus the square root of 5a minus 5 is negative 3? All right, so I need to isolate the radical first because of this negative 8 over here. All right, so how do I get rid of this negative 8? I have to add it to both sides. So I'm going to add 8 to both sides. Square root of 5a minus 5. Negative 3 plus 8. We'll start on my number line. All right, start at 0, go 3 to the left, and 8 to the right, and we'd be stuck at 5. Now I can square both sides. I get 5a minus 5 equals, and 5 times 5, 25. And now I can solve the remaining equation. So add 5, right? 25, 26, 27, 28, 29, 30. Divide by 5 here, and a equals 6. All right, let's do one more example. This next example, a lot of people get hung up on for some reason. So I'm going to go over this one and kind of walk our way through this next one. Okay, the square root of 72 minus x equals the square root of x minus 5. Now, when it comes to the problem like this, I really want to make sure that we know that this square root on both sides is okay, especially since it's isolated. They're both isolated. So my first step then is going to be square both sides. Now I'm left with 72 minus x equals x over 5. Now there's two things about this problem that can give us trouble, right? There's an x on this side and there's an x on that side. And there's this silly little fraction thing. All right, so I'm going to handle the fraction first. So if I want to get rid of that 5, I need to ask myself, what is this operation? Is it addition, subtraction, multiplication, or division? And fractions are division. All right, so how do we get rid of division? The opposite of division is multiplication. So that's gone. That I have to do to one side, or what I do to one side, I have to do to the other. And notice how I put this in parentheses. I'm going to do it to the entire side as being multiplied by 5. So that means I'm going to have to distribute. All right, when I distribute here, I get a big old number. Oh, that's not bad. Yeah, 5 times 72 is 360. 5 times negative x is negative 5x, and that cancels. I'm left with x. All right, now I need to handle, I have x's on both sides. In general, when you have more than one x and you're solving for x, in general, you want to get all the x's on one side and all the numbers on the other. So, since I already have numbers over here and a variable over here, I'm going to take this negative 5x and move it to the other side. I can move terms with addition and subtraction. So it says minus 5x. I'm going to add 5x to both sides. So I get 360 equals 1x plus 5x is a grand total of 6x. Now this is really simple. I could do this in my sleep, right? Divided by 6. That's gone. X. 360 divided by 6. Well, I know 36 divided by 6 is 6. And that other 0 gives me 60.